Hey, what's up? It's your old pal, Mr. Cook, and we're going to work on the Unit 6 group work. So this is going to be the part of Unit 6 where we're working on just right triangle trigonometry. So the first group of problems have to do with 30, 60, 90, 45, 45, 90 right triangles. And just to remind you of what that pattern looks like. With 45, 45, 90 triangles, it's an isosceles right triangle. So that means that the two sides that are across from the 45-degree angles are the same. We call one of those sides x, so that means that the other side is going to be x. And if we use Pythagorean Theorem, we can solve for the hypotenuse, which gives us that same number x, whatever that number is. If it's a 5, then it's still a 5 here, but times the square root of 2. So, any one of the 45, 45, 90 triangles that you see are going to have the same pattern. So I'll just do those real quick. For this first one, if I know that this side is 6, and since this is isosceles, this is also 6. And then the pattern goes that if I know these two sides, then I know this one is going to be that number times the square root of 2. So those are all three of the sides for that one. And then for number 3, what you can do is think about like this hypotenuse, 3, being the same as that x square root of 2. All I need is the x value, because that'll tell me what these two side lengths are. So that's what I'm going to do. I'm just going to take the number that I have, 3 for the hypotenuse, and set it equal to x square root of 2, and then solve. So if I have x times the square root of 2 to get x by itself, I just divide by the square root of 2. And then I can rationalize the denominator. So if I multiply the top and the bottom by the square root of 2, then I get 3 square root of 2 over square root of 2 times square root of 2 is just 2. So that means that x, my side length for this and this, they're going to be the same number, and that's going to be 3 square root of 2 over 2 and 3 square root of 2 over 2. So those are my missing sides. The shortcut for that is if you take this number, whatever the hypotenuse is, for 45, 45, 90 triangle, if you have the hypotenuse, just divide it by 2 and then multiply it by square root of 2. That's the shortcut to get that side length there. And having known that, then I'm going to solve for this triangle's side lengths also for this more difficult diagram. If I know the hypotenuse is 8, if I just divide that by 2 and then multiply by the square root of 2, this turns into 4 square root of 2. So that's each of these side lengths, 4 square root of 2 and 4 square root of 2. There we go. Okay, so that's all the 45, 45, 90 triangles I can solve for. I can't really do anything with this one yet because I don't have any of the sides other than x. So now I'm going to move on to the 30, 60, 90 pattern. So for 30, 60, 90, here's how the pattern for this one works out. So the side that's the smallest, so the smallest of the two legs, you have the hypotenuse. Well, the other two sides are the legs, the ones that make up the 90-degree angle. The smaller of the two of them, if I call that side x, and it's the smaller side because it's across from the smallest angle, 30. If I know this side is x, then that means that the hypotenuse is double that, 2x. And if I use Pythagorean Theorem to solve for this last side length, I get x times the square root of 3. So whatever this value is, x, then I know the other two sides are going to be 2x and x times the square root of 3. So, I have this side right here, 4, which is across from the 30-degree angle, meaning that it's the smallest side, x. So if I double that, then I get the hypotenuse. So 4 times 2 is 8. And then if I take this number and multiply it by the square root of 3, I get the longer of the two legs of the triangle. So that's going to be 4 times the square root of 3. So I've got these two sides figured out. Now, in this case, I've got the side that's across from the 60-degree angle, which is x square root of 3. So if 6 is equal to x square root of 3, then to get x by itself, I divide both sides by the square root of 3. So I get x is equal to 6 over the square root of 3. And if I rationalize the denominator, so multiply the top and the bottom by the square root of 3, then I get 3 radical, I didn't multiply that right. Then it's going to be 6 square root of 3 over square root of 3 times square root of 3, which is 3. And then I can reduce this a little further because 6 divided by 3 is 2. So I get 2 square root of 3 is equal to x. So that's the shortest side, the shortest leg. That's this one. So that is 2 square root of 3. And the hypotenuse is going to be double that. So if I double it, I get 4 square root of 3. Okay, so that's all the sides on this one. Now let's work on the 30, 60, 90 triangles and the more difficult diagrams. So I have this, this shortest leg here. If I double that, that gives me the hypotenuse, which answers my x value. So if the shortest side length is 4 radical 2, then the hypotenuse is double that, so it's 8 radical 2. So that gives me x, the missing side. And then there's a shortcut for finding this side, this x value given this side across from the 60. Here's the shortcut for it. If you take this number, 6, and divide it by 3, that's 2, and then multiply by square root of 3, you get this side. So using that same rule, if I take 9 and divide by 3, that's 3. And then if I multiply that by the square root of 3, that gives me the shortest of the two legs. And then if I have this side, I also have the hypotenuse, because if I double it, I get 6 square root of 3. And then now I have the hypotenuse on this 45, 45, 90 triangle. And if you remember the pattern that we have for that, to find this side as a shortcut, all you have to do is divide this by 2, so that'd be 3 square root of 3, and then multiply that by the square root of 2, so square root of 2. So if I multiply those two together, I get 3 square root of 6, and that's going to be my side length x. And these are more complicated 30, 60, 90 triangles, but if you're just patient with them and you know the patterns for the 30, 60, 90 and the 45, 45, 90, it's actually like pretty easy. So honestly, like the next part's pretty easy. It's just recognizing the ratios, you know, like knowing what the ratio values are. You know, the 6 trig ratios are sine, cosine, and tangent. And then they're reciprocal ratios, which are cosecant, and then secant, and cotangent. These are going to be the reciprocals of these ones. So if you just know what sine, cosine, and tangent are, then you'll know what cosecant, secant, and cotangent are. To know all these ratios, though, you need all 3 sides. And when you have a right triangle, a way to find all 3 sides is, you know, using the Pythagorean Theorem. It's how you relate all 3 sides together. So if you have 2 of the sides, you can solve for the 3rd side using Pythagorean Theorem. I also recognize that this is a Pythagorean triple. It's 5, 12, 13, so I know that this side length is going to be 12, but you can always use Pythagorean Theorem to solve for it. Once we have all 3 sides, relative to this angle, we're going to label the opposite side, which is 12, the adjacent side, which is 5, and then the hypotenuse, which is 13. And we just go through our ratios. So sine is opposite over hypotenuse, so that's going to be 12 over 13. Cosine is going to be adjacent over hypotenuse, so that's going to be 5 over 13. And then tangent is going to be opposite over adjacent, and that's going to be 12 over 5. So those are all the ratios for sine, cosine, and tangent. And then, like I said, these are all just the reciprocals of these. So if I just flip the fraction, I get cosecant, secant, and cotangent, just like that. So if I flip the fraction here, I get 13 over 12. If I flip the fraction here, I get 13 over 5. And if I flip the fraction here, I get 5 over 12. So those are all 6 of my trig ratios for this problem. Next up, number 8, same thing, just use Pythagorean Theorem if you don't have that missing side. So let's see here, 7 squared plus 14 squared equals x squared. 7 squared is 49, 14 squared is 196. If I add those two together, I get 245. And if I take the square root, I get x is equal to the square root of 245. And you can just, keep that as your hypotenuse if you want, but you can also reduce this radical, because 245 is 49 times 5. So I can take the square root of 49 to get 7. So 7 square root of 5 is the reduced radical. And that's what I'm going to put over here, 7 square root of 5 for my hypotenuse. Okay, so relative to this angle, 14 is the opposite side, 7 is the adjacent side, and 7 square root of 5 is the hypotenuse. So again, writing up the same ratios, sine, cosine, tangent. Sine is going to be the opposite over the hypotenuse, so that's 14 over 7 radical 5. And I can reduce that a little bit more. 14 and 7 both divide by 7, so that's going to be 2 over the square root of 5. And you can, rationalize the denominator. I'm not going to do that. I'm just going to leave it as is. Cosine, so that's going to be adjacent over hypotenuse, so that's going to be 7 over the 7 square root of 5. And the 7's reduced, so that means that this turns into 1 over the square root of 5. Tangent is opposite over adjacent, so that's going to be 14 over 7, and that easily reduces down to just 2. Now let's do the reciprocal identities, or reciprocal ratios. So we've got the cosecant, the secant, and the cotangent. All right, so the reciprocal of 2 over square root of 5 is square root of 5 over 2. The reciprocal of square root of 5 over 1 is square root of 5 over 1. Oh, wait, did I say 1 over square root of 5? Oh, well, whatever. The reciprocal of this is square root of 5, and then the reciprocal of 2 is 1/2. And then we've got all 6 of our trig ratios. Okay, so that is through number 8. And then, from here on out, it's just all calculator stuff. So make sure that you have a calculator and make sure that it's in degree mode. If you need to remember how to put a calculator in degree mode, because whenever these calculators, the graphing calculators, get reset, they default back into radian mode. So to put it in degree mode, here's how you do it. You just hit mode, and then it'll look like this. You scroll down to where it says radian or degree, and you highlight degree and hit enter. That puts it into degree mode. Make sure that you do that in your test, because once your calculators are reset, they default back to radians. And if you don't change that, you're not going to get the right answers when you do your trig ratios. Okay, so 9 and 10 and 11 and 12, 13, 14 are pretty quick, so I'll finish up these ones and then I'll start up a new video so that the video doesn't drag on too long. If we're looking for x, we're going to use this angle 31. So relative to this angle, x is the opposite side, 15.4 is the adjacent side. So the ratio that I'm going to use is opposite over adjacent, which is tangent. So the tangent of the angle, 31 degrees, is equal to the opposite side, x, over the adjacent side, 15.4. And then when we want to solve for x, we just, if it says x over 15.4, dividing by 15.4, the way that we get rid of division is by multiplying, so we multiply both sides by 15.4, and we get 15.4 times the tangent of 31 degrees is equal to x. And then we can just, type that into our calculator and find out what x is. We're rounding to 2 decimal places, so let's see what it's going to be equal to. All right, 15.4 times the tangent of 31. All right, so that's going to be 9.25, right around 9.25. And then always check for units. This doesn't have units, so that's going to be our answer. All right, now using this angle, 29, we have the opposite side, and we're looking for the hypotenuse. Opposite and hypotenuse is sine, so we're going to use sine now. The sine of 29 degrees is equal to the opposite side, 3, over the hypotenuse, x. So when you solve this problem, you can just make it into a ratio like this, sine of 29, because it's just a number over 1 is equal to 3 over x, and then you can cross multiply to solve it. So I'm going to do that first, and then I'll show you a shortcut for it. If we cross multiply, we get 1 times 3, which is 3, is equal to x times the sine of 29. And then to get x by itself, we divide by the sine of 29, and we get x is equal to 3 over the sine of 29. But of course, if you look at the original expression that I have and then where we ended up, this solving process is going to be the same every single time. We start here, we end up here. And if you look at the ratios real quick, 3 over x to 3 over sine of 29, all you really need to do is just switch these two around. See? If you switch them, then you get the right ratio. Anyways, so if I plug that into my calculator, let's see what we get. 3 divided by the sine of 29, you get 6.19. Okay, so there's our approximate answer to 2 decimal places. All right, for this one, we need to put together our triangle. So, just start drawing it out. We know it's going to be a right triangle. The angle C is going to be a 90-degree angle, so there's where C is. And then let's just put A and B over here, because those are the other 2 vertices, it looks like. B is a 13-degree angle. Doesn't really look like it on my diagram, but whatever. BC is 6.2, and we're looking for AB, so let's call that X. So relative to this angle, this 13-degree angle, we have the adjacent side. We're looking for the hypotenuse. So adjacent over hypotenuse, that's cosine. So we're going to use cosine here. The cosine of 13 degrees is equal to the adjacent side, 6.2, over the hypotenuse, x. So then, this is the same situation as this one, so let's use a little shortcut. If I just change these 2 numbers around, I get x is equal to 6.2 over the cosine of 13. And remember, that only works, this shortcut will only work when x is in the denominator or your variable's in the denominator. Because if you look at this one, the first one we did, x is in the numerator, and I just had to multiply this number over here. So, it doesn't always work, but it's a shortcut for when the variable's in the denominator. All right, so let's see what that is approximately equal to with our calculator. So 6.2 divided by the cosine of 13, and you get 6.36, so right around 6.36 for our answer. All right, so that's through the first 11 problems. Now let's finish it off through these ones. So find the indicated missing angle of the right triangle, and then round answers to 2 decimal places. So we're going to 2 decimal places again. And when you're solving for a side length, you're going to use sine, cosine, tangent. When you're solving for an angle, you're going to use sine inverse, cosine inverse, and tangent inverse. Those can be found on most of your calculators by just hitting the second button here, and then, you know, sine or cosine or tangent. So that's how you can access it on your calculators. And it's really easy to use. You know, like for this angle, all you got to do is just figure out what sides you have and then build your ratio and solve. So relative to this angle, we have the adjacent side and the hypotenuse. Adjacent and hypotenuse is cosine, so it's going to be the cosine inverse of the adjacent side over the hypotenuse, and that gives us our angle measurement. So let's see what that's going to be equal to on our calculator. So second cosine 3 over 4, and we get right around about 41.41 degrees. And make sure that you put your degrees on there, because that's the units on the angle. And you know, it's important to put units on your angles. All right, next one. So relative to this angle, we have the opposite side and the adjacent side. So that's going to be tangent. So we do tangent inverse of the ratio, opposite over adjacent, and then plug it into our calculator. So our angle is going to be equal to, close to tangent inverse of 8 over 12. So it's pretty close to 33.69 degrees. All right, there we go. And let's go over to our last one, number 14. And again, need to build a diagram for this. So C is going to be our 90-degree angle. And then let's see here. Let's put A over here and B over here. So AB is going to be 22. AC is 17. And we are looking for the measurement of angle B. So relative to angle B, we are given the opposite side and the hypotenuse. Opposite and hypotenuse is sine. So we do the sine inverse of the ratio, so 17 over 22. And then that'll give us our answer on our calculator. So second sine, 17 over 22, enter, and we get our angle measurement. So that's going to be 50.5, no, let's round that up, so 60. So 50.60 degrees. And there's our answer. Okay, so that's the conclusion of the first page. And looks like we're just under 20 minutes on this. This is about like the amount of time that you'd want to spend on all this stuff, you know, because I've spent a ton of time going through each of the steps and all that stuff, but realistically, you could probably get done with these parts pretty easily. So target right around 20 minutes or less, so you have a good 30 minutes or more to work on like the word problems and stuff. All right, so that's this side of the page, so let's end the video and move on to the next one.